Okay, so we are recording the screen just to make sure that people who are not here today can see what we're doing. So we're going to work through this little worksheet and we're going to graph at the same time. So everybody doesn't need to have Desmos because you're going to get overwhelmed with the stuff in your space. So let's look at the first question. It says, exponential function is a function in which the variable is well, we're going to fill this in. An exponential function means that the variable is an exponent. The variable is an exponent. It's described as a function in the form y equals a times b to the power of x, when b is the base and a is the constant. Yeah. So a cannot be 0. That's the only rule. A can't be 0 and b has to be greater than 1. Okay. Or greater than 0, greater than 0, but not equal to 1. Because if it's 1, it doesn't change. So let's look at this first one. The first question, example number 1, says graph the exponential function using a table of values. So we're not going to use Desmos yet. We're going to use a table of values. Do you guys remember filling out a table of values to solve linear equations? So this just says the function is 3 to the x, and this says let x equal -2. So this becomes 3 to the -2 power, and 3 to the -2 is the same thing as what? What happens when I have a negative exponent? I have to do what with it? Drop it. So that's the same thing as 1 over 3 squared. And 1 over 3 squared is what? What is 3 squared? Yeah, this becomes 1/9. I know you can hardly see that. Maybe I can not do the minimize right now and just make this big for a second. Just for this part. Okay. So now let's do 3 to the -1 power. 3 to the -1 equals, well, that's the same thing as 1 over 3 to the power of 1, right? But we really don't write it like that. We just say it's 1/3. What about when 3 is raised to the power of 0? Well, let's see. 3 to the power of 0 equals anything to the 0 power is 1. Good job. 3 to the 1/2. This is a really cool, it looks like this. This is called a rational exponent. 3 to the 1/2 is the same thing as the square root of 3. So when you take something to the 1/2 power, that means take the square root of it. So the square root of 3, I already did in the calculator, is about 1.7. Okay. Now let's let x equal 1. So when x is 1, I have 3 to the first power, which is just 3. When x is 2, I have 3 squared, which is the same thing as 9. So we're going to graph this on this little teeny tiny graph over here, and I'm going to show you how I numbered this. So I went over 1, 2, 3, 4 spaces and called this number 1. And then I went over 1, 2, 3, 4 more spaces and called this number 2. And I did the same thing on the negative side, over 1, 2, 3, 4, and called this -1, and over 1, 2, 3, 4, and called this -2. And then to count my y-axis, I went up like this, every other one. So skip 2, so 1, skip 1, 2, skip 1, 3, 4. So it's like 1/2 1, 1.52, 1.53. Does that make sense? So every other one is going to have a slash on it. And when you do that, 9, we need the number 9, actually is this number right here, right off the grid. It's one graph mark off the grid. I'm going to put my 5 right here. Wait, 1, 2, 3, 4, 5, 6, 7. I lied. 9 is up one more. 9. Okay. So we're going to just plot these points that we just got from our table. We're just going to plot these points as best as we can. It's not going to be perfect. The first 2 that we do are going to be drawn manually, right? So there's no way to draw fractions perfectly on a coordinate grid. So the first point, when x is -2, I want to be at 1/9. Well, this mark right here is 1/2. 1/9 is much smaller than 1/2, so I'm going to put it right on the line right above the 2. Just that teeny little dot right above the -2, right on the line. Do you guys see that? When x is -1, y is 1/3. So 1/3 is almost a half. So I'm going to take that and put it almost to the 1/2 mark. It's almost a half, not quite. Again, this is a general estimation. When x is 0, y is 1. So that's this point right here. When x is 1/2, here's where x is 1/2. That's at 1.7. So it's almost to the 2. Almost to the 2. This is the 1/2 mark. So we're at 1.7 is going to be almost to the 2. When x is 1, y is 3. 1, 2, 3. And when x is 2, y is 9. So when you connect your graph, your dots, it looks something like this. So this is what an exponential function looks like. It means it grows exponentially. It starts off really small, but then it grows really fast. You see how those numbers are going to get way bigger. When x is going to be 3, it's going to be 27. 4, it's going to be 81. 5, it's going to be 729 or 343. It's just going to keep growing and growing, okay? So now let's go to the next function. But we have a question. It says, what is the y-intercept of the graph that we just did? What's the y-intercept? Where does this graph cross the y-axis? At 1. What was the input value of this? To get 1, oh my God, that just made me sick. To get 1, to get an output of 1, what did we input? 0. So the y-intercept is 1, and it happens when x equals 0. That sounds really familiar to a linear function, right? Crosses the y-axis when x is 0. Nice. What is the domain? Remember, the domain is all of your input values. So we can input, we can input any x value. So the domain is all real numbers. The domain is all real numbers. But what is the range, meaning the y values? Well, you can see from this graph, what's the smallest y value? Is that going to go below the x-axis? It's not. So everything that we graph in the range is going to be greater than what? Greater than 0. Y such that y is greater than 0. And let me explain to you why really fast. If I had 3 to the negative 100 power, that's the same thing as 1 over 3 to the 100th. And 3 to the 100th power is never going to be 0. 3 to the power of 100. Whoops. I'm putting it into a calculator. That equals 1.94 times negative 48, 10 to the negative 48. That means that decimal, remember we talked about scientific notation, that decimal is going to move 48 spaces to the left. So it's going to have 47 zeros, 0.4700194. That's a really small number, but it's not 0, right? It's never going to be 0. That's why it's greater than 0. Okay, let's look at this next one. So we're going to fill out a table of values for this one as well. So let's let x equal -2. So that's saying 1/2 to the power of -2. But when you have something raised to a negative power, that means you have to reciprocate it. So if I flip this, this becomes 2 over 1 squared. And what is 2 over 1 squared? 4. Okay. Let's take 1/2 to the -1 power. Well, that's the same thing as 2 over 1 to the first power, which is just 2. Let's take 1/2 to the 0 power. Well, I know that anything to the 0 power is 1. Let's take 1/2 to the 1/2 power. That means the square root of 1/2. So in your calculator, you're going to just do the square root. You can do 1 divided by 2, or you can do the square root of 0.5, and you're going to get about 0.71 or 0.7. Let's take 1/2 to the power of 1. Well, anything to the power of 1 is just that number. So that's 1/2 or 0.5. That'll help us when it comes to thinking about this. I'm going to write equals 1/2, which is 0.5. And then 1/2 to the power of 2. That's the same thing as saying 1/2 times 1/2, which is 1/4 or 0.25. So I'm going to number my x-axis first. And I numbered this the same way I did the last one. 1/2, 1, 1/2, oops, 2. And then on the opposite side, I did the negatives the same way. So negative 1/2, negative 1, negative 1.5, negative 2. And then when I counted my y-axis, I went up to 1/2, 1, 1/2, 2, 2 and 1/2, 3, 3 and 1/2, 4, just like that. And now I'm going to plot my points. So when x is negative 2, y is all the way up here at 4. When x is negative 1, y is at 2. When x is 0, y is at 1. When x is at 1/2, that's right here, y is at 0.7, so it's almost to the 1. It's above the halfway mark, right? When x is 1, y is 1/2. And when x is 2, y is 1/4. So this graph is going to go this way. So I just want to kind of scrunch it up so you can see both functions. So the green function looks different than the red function, right? The green one, if you think about it, as x gets bigger, as the x values get bigger, the y values get bigger. That means it's increasing. But the red function, as the x values get bigger, what's going to happen to the y values? They're getting much, much, much smaller, right? So this function is decreasing. All right, so let's talk about the intercepts. What's the y-intercept? Say again. Yeah, the y-intercept is 1, and that happens when x equals 0. What is the domain? Again, all real numbers. We can input any number here. What is the range? What's the smallest y value possible? Is this line right here, is this graph ever going to go below into negative y values? Let's think. If I took 2, you notice that as the exponent gets bigger positive, the number gets really small. So if I took 1/2, right, and I raised it to the power of 100, that's still not going to be below 0, right? So it's the same thing as the last one. Y such that y is greater than 0. Okay. Now we're going to split our screen and we're going to start graphing. Okay. So We are going to use Desmos and graph the function f of x equals 2 to the power of x. So over here in Desmos, I'm going to type f parenthesis x equals 2, and then I'm going to hit shift caret. Shift caret, that's the number 6. Shift number 6 gets you the caret function. That raises something to a power. And I'm going to put, I need to put this in a parenthesis really fast. Sorry, my 2 needs to be in a parenthesis. Shift caret, and I'm going to put the x right there. Let's look at your graph. So it asks you to evaluate the function when f equals 0 at f of 0. That means x is 0. So I'm going to go to where x is 0, and I'm just going to touch that spot. What is at f of 0? Remember how to evaluate a function? F of 0 equals 1. F of 0 equals 1. Let's see what happens when f is 2. So I'm going over 1, 2, and I'm going to drag it up, and I'm going to click right here. And it should give me a point. So you can get really close. What do you guys think it is? When x is 2, y is, well, 2 squared is 4, right? So this equals 4. F of 2 equals 4. This is going to be tricky. F of 2 equals 4. What about f of negative 1? So go to where x is negative 1 and scroll up and try and touch that spot. And you see that you have, when x is negative 1, you have the point 1/2. It's 1/2, I promise you. So equals 1/2. And then I want you to sketch that. Just do your very best to sketch that graph. So I'm going to slide up and try and sketch it with you. So I'm going to just copy the graph that I have here. So I know that it crosses the y-axis at 1. When x is 1, y is 2. We didn't write that, but it is. When x is 2, y is 4. I know that when x is negative 1, it's at 1/2. And I'm just going to try to draw this on my paper. Something like this. We're just putting a sketch there. You're just making a sketch. Are you with me or are you not with me? Okay, let's go to g of x. So I'm going to use the same function. I'm going to change the f to a g. And the only thing that we're changing is g of x has a negative outside of that 2 parenthesis. So, I wonder what's going to happen. Any ideas? What happened to our graph? What did it do? It actually did what? It reflected over the, you guys know what the word reflection is. It reflected over the x-axis. Yeah. So let's evaluate this function. So we have to figure out what's going on when when I let x equal 0. So when I let x equal 0, g of 0 is negative 1. When I let x equal 2, 1, 2, I have negative 4 instead of positive 4. And when I let x equal negative 1, what do you suppose the answer is going to be? Negative 1/2. Yeah, notice that these are inverses of each other, right? They're inverses of each other. So we're going to try our very best to sketch this graph. So we know when x is 0, y is negative 1. When x is 1, y is going to be negative 2. When x is 2, y, oh, I see this. This is counting by, hang on a second. Let me erase. Eraser. This is counting by halves, like each increment is a half. So when x is 0, y is, you little stinker. I can't get to the tools while it's, there we go. Y is 1. When x is 1, y is negative 2. When x is 2, y is negative 4. When x is negative 1, we said this was negative 1/2. Negative 2 would give us negative 1/4. So our graph looks something like this. It should be a reflection. It should be a reflection over the x-axis of the graph you drew in the top. Okay. Questions on that? So if you're doing this with me, you should be either in Desmos graphing and that's it. So if I see you in something else, I'm just going to send you down to ALC. Stop doing whatever you're doing. So what does the negative do to that graph? What does that negative do to the graph? What did we say it did? Yeah, it reflects it over the x-axis. So reflects over x-axis. It's really hard to write on half of a screen. It reflects over the x-axis. Is this function, which one of these functions is increasing? Meaning as x gets bigger, y gets bigger. The first one, f of x equals parenthesis 2 to the power of x. Which one is decreasing as x gets bigger, y gets smaller? The second one, g of x equals negative times 2 to the power of x. Thoughts? Are we doing okay? Are you still with me? Okay. All right. We have a new function here. So I'm going to take this g and I'm going to replace it with an f again. And I'm going to get rid of the negative that's in front of my parenthesis, and I'm just going to replace it with a 4. Jordis, what do you need? Nope, we got to do this. I'm going to replace it with a 4. So what did that do to my graph? It took the 2 to the power of x and it stretched it. It took every output and multiplied it by 4. That 4 out front is a multiplier, right? So f of 0, when x is 0, what's my output now? What is that point? 4. That's because 2 to the 0 power is 1. And 1 times 4 is 4. F of 2, when I let x equal 2, you can scroll all the way up here and see that when x is 2, it's going to be right here at 16. Because 2 squared is 4, and 4 times 4 is 16. When x is negative 1, so let me go big again. When x is negative 1, my graph is at, when x is negative 1, what am I about? It's at negative 2. Yeah, it's not at negative 2. It's at positive 2. Because 2 to the negative 1 becomes 1/2. And half of 4 is 2. So this is 2. Oh, it says negative 2. Is that what you said to me? Yeah, good call on that. Sorry. So at negative 2, it's a 1. Because that becomes 1/4 of 4. So this is a 1. So it says, how is the graph of this function different than the graph from function 1? Well, all of our outputs have been multiplied by, can you not wait till instruction is over? Okay, go. So how is the graph of this function different than the other one? All of the outputs have been multiplied by what? What's the multiplier we have there? What's that number outside of our, yeah, all of the outputs are 4 times bigger. Okay, we're almost done. Sketch your graph. So at 0, it's 4. At 1, it's going to be 8. At 2, it's going to be 16, which is going way off your graph. At negative 1, that's 1/2 of 4, which is 2. At negative 2, it's 1. So it's going to look something like this on your sketch. Something like that. All right, so for our next graph, we're going to graph the same exact function, except we're replacing the 2 raising to a power, and what are we putting in there? What does example 5 say to do? 1/2. So just turn this 2 into a 1/2. What do you think is going to happen? It reflects over the, yeah, good job. So let's evaluate our function again. So g of 0 is still 4, but g of 2 is 1. It's 1/4 of what this output was, right? It's like a fourth of what your output on the front side was. And g of -2 is probably going to be 16. Because 1/2 to the -2 power is 4. So where does this graph cross the y-axis? At 4. So it looks like y equals a times b to the x power. It looks like a is the y-intercept, doesn't it? I think every single time the number outside the parenthesis is where we cross the y-axis. And if there is no number outside the parenthesis, it's understood that that number is a 1, which is why on the first 2 examples we crossed the y-axis at 1. Okay. All right. So let's sketch this graph really fast, and then we're going to just do some basic filling out some notes, talking about what you just hopefully just learned. So when x is 0, y is 4. When x is 1, y is 2. When x is 2, y is 1. When x is -1, y is 8. And when x is -2, y is 16. So this graph looks something like this. Yes, let me write you a note. Pen's dead. There you go, sorry. You're welcome. Okay, questions. Do you guys see how to use Desmos? Do you feel like you can use this as a supplement to graphing? Okay, so I'm going to get rid of this, and I'm going to go back to a full screen, and we're going to finish up our notes. Okay, so the general exponential function is in the form y equals a times b to the power of x, where a is the initial, sometimes it's called the initial value. But we know from linear functions that when we say what's the initial value, that means the y-intercept. Okay. B is known as the base or the multiplying factor. B is the base, like 2 to the power of 2 or 2 to the power of 3. We call this the base. We've been calling that the base, right? When we deal with exponents, this is the base. This is the number that I'm raising to a power, okay? Questions about that? And switch the b around, it's a math. I knew that that was going to be an issue, but it's written like this. Like I couldn't change it. So b always used to be the y-intercept, but in an exponential function, b is the base. Sorry, you're just going to have to embrace it and love it. I didn't create it, otherwise it would be different. Okay, so here we go. We're going to talk about graphing this function, and I'm just going to I'm going to pull it up on Desmos. So I'm going to graph the function h of x equals 54 to the 1/3 x. And you guys are just going to look at it. We're not going to split the screen or anything. I just wanted you to see it nice and big. So h of x equals 54. And this fraction is going to become 1/3. So here's something that I've hoped you've noticed, okay? I hope you notice that when the base is a fraction, the function is decreasing. When the base is greater than 1, I'm talking about that number that we're raising to a power, the function is increasing. Okay? So it says evaluate the function at h of 1. So when I see 1, when I let x equal 1, this crosses the y-axis at 18. So it's when x is 1, the output is 18. So h of 1 is 18. H of 2 is 6. And h of 3, I can grab it for you, is 2. H of 3 is 2. So put those in there. So it says, as x gets bigger, what's happening to your y value? As x gets bigger, what happens to the y value? Anybody? It gets smaller, so that means it's decreasing. Yes. It gets smaller, which means it's decreasing. So if I were to graph this function, we're gonna just fill it out. I'm not gonna go back to the graph. This is gonna be what? This number right here is bigger than 1. So as x gets bigger, this is gonna get larger. Y gets larger. And this means that this is increasing. So the function y equals a times b to the power of x will increase or grow, exponential growth, if b is greater than 1. The function y equals a times b to the power of x will decrease, exponential decay, if 0 is less than b is less than 1. That's how we have to write that it's a fraction, right? It's a number in between 0 and 1. It can't be 0. Remember, those were the definitions. A can't be 0, B can't be equal to 1, and it can't be 0 either. Okay? So use what you know to write the equation. So we're going to write this equation based off of this table. So remember that A is the y-intercept, and B is the base. So remember that the y-intercept happens when, so what's the y-intercept? Y-intercept is 2. So I'm going to start off with y equals, I'm going to replace A with the number 2. And then I'm going to have a parenthesis to some power of x. We have to figure out what goes in the parenthesis. So much like a linear function, which grows by plus or minus something, this grows by a multiple. What did I do to go from 1 to 2? I multiplied it by 2. Does that repeat? What did I do to go from 2 to 4? Multiplied it by 2. What did I do to go from 4 to 8? Multiplied it by 2. Multiplied it by 2. So this number that goes in here is a 2. So I'm going to write a little note that says, because I want to remind you that linear functions grow with a plus or a minus a number, right? When we look at a table, we call that the slope or the rate of change, and it's by adding or subtracting a constant number, right? But exponential functions grow by a multiple, meaning we multiply a number, okay? That's the difference. So knowing what you know, look at example number 9, and someone tell me if they can come up with a equation. Where does it cross the y-axis? And what am I doing? What am I multiplying by each time? It is 1/2, yeah. Sometimes we want to say divide by 2, but remember dividing by 2 is the same thing as multiplying by a half. We're multiplying by a half each time, so 1/2 to the power of x. So now we're just going to look at these and tell if we're going to identify the y-intercept and tell me if it's increasing or decreasing. I tried to trick you on these a couple of times, so be wary. So, A, what's the y-intercept? It's 8. Is it increasing or decreasing? How do you know? It's decreasing because, yeah, it's decreasing because this base is less than 1. 3/4 is less than 1. That's how I'm going to show it, okay? What about B? Is it increasing or decreasing? Oh, sorry. What's the y-intercept? I got ahead of myself. 2. Is it increasing or decreasing? It's increasing. Why? Because 1.5 is greater than 1. Let's look at example C. What's the y-intercept? 3. Is it increasing or decreasing? It's decreasing. Because 1/2 is less than 1. Are you guys getting this? I mean, I know it looks scary, but I think this was the best way to learn it. I don't know. Tell me about D. Y-intercept is it increasing or decreasing? Hurry up, pick it up. Oh, I thought it was sorry. I thought it was a soda, sorry. Is it increasing or decreasing? I heard both. Decreasing? Why do you think it's decreasing? Is 5/2 less than 1? No. What is 5/2? Same thing as 2.5. 2.5 is greater than 1. Watch out for that, okay? So this is increasing. Just because it's written as a fraction doesn't necessarily mean it's less than 1. It could be an improper fraction. So watch for that. Okay, so I want to talk to you about your homework. So in your packet for today, your homework is on pages 13 through 16. Yeah, there's 13 questions. 13 questions. I promise you it's going to go really fast. You have 13 questions between these 4 pages. 13 questions. You also have an exit card. Some of you guys did it yesterday because it popped up on your to-do list. I had made it for yesterday, but remember we had to push everything back. So you have an exit card on using exponent properties. It's open until midnight tomorrow night. Don't wait till midnight tomorrow night to do it, but get it done. Tomorrow, I'm telling you that I'm going to teach a lesson, and then you are going to do a 5-question quiz on exponents. 5 questions, okay? All right. Jordan.